Series parallel resistive circuit. A circuit consists of the combination of resistors connected in series and parallel. Series parallel resistive circuit rules. Let us recall some rules associated with series circuit and parallel circuits. In series circuit, we know that P total equals P1 plus P2 plus P3. E total equals E1 plus E2 plus E3. I total equals I1 equals I2 equals I3. And R total equals R1 plus R2 plus R3. In parallel circuits, P total equals P1 plus P2 plus P3. E total equals E1 equals E2 equals E3. I total equals I1 plus I2 plus I3. And R total is actually 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. Don't forget about Ohm's law. See my 4th video, Ohm's law. Series circuit. Let us add resistance in series. Recall R total equals R1 plus R2 plus R3, and we're given the following. R1 is 10 ohms, R2 is 25 ohms, R3 is 5 ohms. So step 1, draw a picture and label the resistors. R1 equals 10 ohms, R2 equals 25 ohms, R3 equals 5 ohms. So step 2, combine and redraw as one total resistor. RT equals 40 ohms. Parallel circuits. Let's add resistance in parallel. Let's recall 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. Given the following, R1 is 10 ohms, R2 is 25 ohms, R3 is 5 ohms. Step 1, draw a picture and label the resistors. R1 is 10 ohms, R2 is 25 ohms, R3 is 5 ohms. Step 2, combine and redraw as one total resistor. RT is 2.941 ohms. Series parallel circuit. Let us add resistance in series and parallel. Given the following. R1 is 10 ohms in series with R2, which is 25 ohms, and then R3 is in parallel with R1 and R2. Let's draw a picture and label the resistors. We have R1 is 10 ohms, R2 is 25 ohms, R3 is 5 ohms. Step 2, redraw with one resistor combined with another. Hint, only one at a time. So I'm going to combine the top two resistors in series. R1 plus R2 is 25 ohms, and R3 is still 5 ohms. Step 3, we'll repeat the same step until you are left with one resistor, which is R total. And R1, R2 is in parallel with R3, which gives us 4.375 ohms, which is our R total. Series parallel circuit. Let's add resistance in series and parallel. Given the following, R1 is 10 ohms in series with R2, 25 ohms, and R3, which is 5 ohms. R4 is 15 ohms in parallel with R2 and R3. Let's draw a picture and label the resistance. R1 is 10 ohms, R2 is 25 ohms, R3 is 5 ohms, and R4 is 15 ohms. Step 2 is to redraw one resistor combined with another. Hint, only one at a time. I am going to combine R2 and R3 in series first. Therefore, R1 is still 10 ohms, R2, R3 becomes 30 ohms, and R4 is 15 ohms. Step 3, which is repeat step 2 until you're left with one resistor. Next, I'm going to combine R2 and R3 in parallel with R4. So R1 is still 10 ohms, but now the combination of these guys become 10 ohms. Step 4, one last time, I'll combine the R1 with the total and get RT, which is 20 ohms. Series parallel circuits. Let us find all the current and voltage in a series parallel resistive circuit. We're given the following information. R1 is 10 ohms in series with R2, which is 25 ohms, and R3, which is 5 ohms. R4 is 15 ohms in parallel with R2 and R3, and the source now is 480 volts. So similar to the previous slide, we're going to do all this step just a little bit faster. You can fast forward a little bit if you are comfortable with the combining series parallel circuits. Now we add the source to the circuit. So the source is E total 480 volts. With Ohm's law, I can find current total, and I get 24 amps. So now, going backwards, these resistors broke out into a series circuit. So we're back to series, we carry the current back. I can say that I1 now is 24 amps, and R2, R3 parallel R4 is 24 amps. And I can find the volt drop. E1 is 240 volts. E2, 3 parallel 4 is 240 volts. Now going back again, the resistors on the right became a parallel. Therefore, I'll bring that voltage back of 240 volts to both of those resistors. With volt drop, I can find now current draw on each of the rungs. I1, I2, and 3 becomes 8 amps, and I4, I get 16 amps. And the sum of those two still equals 24 amps. Going back one last time, the top resistor, R2, R3, broke out into a series. So we're back to series, carried the current back. I can say I2 and I3 will both see 8 amps. And with Ohm's law, I can find the volt drop of E2, which is 200 volts, and the volt drop of E3, which is 40 volts, and they add up to 240 volts. Thank you for watching. If you haven't yet liked or subscribed, please do so, as it is an indicator that you're liking my content. If there are any concerns, please feel free to leave a comment. Have a happy learning experience. And if there's something that you guys want to see, I'm working towards the electrical code right now and have that for you guys. Have a good one.